So in today's lesson, students will be able to add and subtract rational numbers. So once again, rational numbers in short mean like fractions, right? So like 1/2 is a rational number. But to be clear, so is 0.5 because I can convert 0.5 back into a fraction. When you see rational numbers, just think of fractions. However, it could also mean whole numbers and decimals because you can convert whole numbers and decimals into fractions. It kind of looks like a lesson that we had in the past, right? It's just adding fractions, but now we have negative fractions. So we're going to call it rational numbers instead. So everything else is pretty much the same. It's just a lot of rules that we're combining all at the same time, but you pretty much know everything you have to do. So when we add or subtract fractions, you need common denominators. Well, we have great news here. Denominators are already the same. You can still use that birthday cake method that we talked about earlier in the school year. I put both 5s inside the birthday cake. I pull out a 5. 5 goes in 5 ones. 5 goes in 5 ones. And then make that L shape for the LCM, right? We're finding the LCD. And 5 times 1 times 1 is 5. So you could do that if you wanted to. You really don't need to because the denominators are already the same. It doesn't really matter. So we're going to make both denominators 5. Now, because you're multiplying 5 by 1 to get 5, you're multiplying 4 by 1 to get 4. In short, you're not changing the denominator, so you're not changing the numerator. Same thing here. You're timesing this 5 by 1 to get 5, so you're timesing this 3 by 1. One thing I want to make clear, though, see how it says negative? Always give the negative to the top number, the numerator. So I'm treating it as negative 3, I mean, times 1, which is negative 3. Always move the negative to the top, to the numerator. So now I'm doing 4/5 plus negative 3/5, and because the denominators are the same, I just focus on adding my numerators. 4 plus negative 3, right? Signs are different, so technically I subtract, and the positive has more players, so my answer is going to be 1 over, and I keep my denominator the same. My answer is 1 over 5. This example, I made it a little bit more complicated than I should have, but I want you to see a method that works all the time. I want you guys to do this no matter if the denominators are the same or different. Once again, I'm going to rewrite it, and I'm going to make sure that all my negatives are on top. So it's 1/5 plus, I'm rewriting it as negative 2 over 3. I just take the negative and I bring it to the top. Here my denominators are different, so here it'll make more sense why I did what I did before. So I put the 5 and the 3, the two denominators, inside the house, and I pull out whatever they have in common. In this case, I only have a 1 in common. 1 goes into 5, 5, and 1 goes into 3, 3 times. I make that L shape and I multiply. 1 times 5 times 3 is 15. You want both denominators to be 15. Now to go from 5 to 15, you had to times by 3. What you do to one side, you do to the other side. 1 times 3 is 3. 3 times 5 is 15. What I do to one side, I do to the other side. And negative 2 times 5 is negative 10. And now, because the denominators are the same, I can now add the numerators, the top numbers. 3 plus negative 10, signs are different, so technically I subtract. This time the negative has more players than the positive, so I subtract and I get 7, but the negative team wins, so it's negative 7, over, and I keep my denominator the same. Always check to reduce, but in this problem I did not need to reduce. I'm going to skip a few problems now. You have to complete them on your own, but I want to go into mixed numbers. And now we're going to solve this problem. 1 and 1/3 plus negative 2 and 1/3. Here, because they're mixed numbers, you want to go around the clock and make them improper fractions. Right? You don't have to do this, but it's an easier way to solve these problems. Plus, when you multiply and divide, you have to do this step anyway. 3 times 1 is 3, plus 1 is 4. It's 4 over 3. Plus, don't worry about the negative. Pretend like the negative's not there. Just do 3 times 2, which is 6, plus 1, which is 7, is 7 over 3. However, now take the negative and bring it down. Once again, I put the negative on the top, on the numerator. And here I solve again. This time I'm going to solve it a little bit easier. If the denominator is already the same already, you don't have to do any extra work. Just focus on the numerator if the denominators are the same. So I'm just going to do 4 plus negative 7. 4 plus negative 7, signs are different, so I subtract, and the negative team has more players than the positive team. So it's going to be negative 3 over 3. Here I can reduce, and I'll get negative 1. One more example, and then you can do the rest on your own. Last example is 2 over 7 minus 4 over 7. I recommend you using keep, change, change whenever you see a subtraction problem. So you're going to keep, change, change. So it's going to be 2/7, change the minus sign to a plus sign, and change 4/7, right, positive 4/7 to negative 4/7. And now you're going to solve. Once again, this time I'm going to do it a little bit easier. Here the denominators are the same, so I don't have to worry about the birthday cake method or anything like that. I can just focus on the numerators. And 2 plus -4 is going to be -2. Signs are different, so I subtract, and the negative team has more players than the positive team. And I keep my denominator the same. My answer is -2 over 7. Is just like with fractions, multiplying is a lot easier. So whenever the signs are the same, so I'll give you two scenarios. One is if they're both positive, so a positive times a positive equals a positive. Or if they're both negative, meaning a negative times a negative. Both answers will get you a positive answer, right? So whenever signs are the same, it's a positive answer. Whenever signs are different, it's a negative answer. So for example over here, if you have a negative times a positive, or if you have a positive times a negative, they will both get you a negative answer. So I'm going to do the examples below, and that's pretty much all I'm going to do. I'm not going to do any more than these two for multiplying fractions. The first thing I recommend is just getting the sign first. So -1/2 times -3/4. Well, a negative times a negative is a positive. You can even put a little plus sign here if you want for now, so you know it's a positive, or you just leave it alone. Like, don't write anything down. If it's a negative, I will put the negative sign. So I think for now, for a visual, I'm going to put a little plus sign, knowing that it's positive. Now I can just cross out these negatives. I don't need them anymore. Now I'm just solving 1/2 times 3/4. It's exactly what we did in September. So I multiply. When you multiply fractions, you don't need common denominators. So it's just simply 1 times 3, which is 3, and 2 times 4, which is 8. I like to reduce, right? Simplify before you multiply. However, in this scenario, there is nothing for me to cross cancel. Because of that, I don't need to worry about reducing afterwards, meaning my answer is just 3/8. So now I'll do this example here. Here I have a positive 1/2 times a negative 3/4. So a positive times a negative is a negative. So right away, I'm going to put that negative sign. Now I can cross out this negative because I don't need it anymore. I know my answer is going to be a negative fraction. From here, once again, I don't need to worry about common denominators when I multiply. So I'm just going to multiply my numerators and my denominators and call it a day. 1 times 3 is 3, and 2 times 4 is 8. The negative, I like to leave it on the top, like I said in my last lesson. I like to leave it in the numerator, but you can technically leave it in front, in the bottom, on top. It doesn't really matter. Once again, I like leaving it on top. It's actually the easiest way. So my answer is -3/8. I'm going to do two examples with you. We're dividing, and then the rest is on you. So when we're dividing rational numbers, same rules as multiplication, right? When signs are the same, meaning a positive divided by a positive, you get a positive answer. And if both of them are negative, so negative divided by a negative, you're still going to get a positive answer. If signs are different, meaning a positive divided by a negative or a negative divided by a positive, they both will get you a negative answer. It has nothing to do with players, absolute value, whatever you want to call it. So the only thing I really want to go over here is, look at that. I mean, that looks like a really complicated fraction, and that's because it's called a complex fraction. So we're going to rewrite it so that's easy for you to solve, and then just take it from there. So if you notice in this problem here, this fraction goes together. It's 2/7, so I'm just going to write it out as 2/7. This longer fraction bar means division. So it's going to be 2/7 divided by, and then I have a whole number, 8. And then from there, I do the same rules as before. First, let's get the sign, right? So it's a positive divided by a positive, so my answer is going to be positive. So once again, I'm going to remind myself the answer is going to be a positive. You don't have to do this step, up to you. From here, when I divide fractions, I can't forget the keep, change, flip acronym. I'm going to keep 2/7. I'm going to change the division to multiplication, and I'm going to flip 8, but this is where it gets confusing. 8, it's not a fraction, right? So we got to make it a fraction first. So I'm going to make it 8 over 1, and then I'm going to flip it. And when I flip it, it's going to become 1 over 8. And now I'm going to solve. It's still a positive times a positive, which gets me a positive. Here I can cross cancel. So instead of doing 2 times 1 is 7 times 8, I noticed that 2 and 8 have a number in common. 2 can go into both numbers because they're both even. So then I do 2 divided by 2, which is 1. And I do 2 divided by 8, which is 4. And then I will multiply. 1 times 1 is 1. 7 times 4 is 28. My final answer is positive 1 over 28. All right, one more example, and then the rest is on you. For this problem over here, and I'll rewrite it, 3 divided by, I like to put the negative on top once again, so I'm putting the negative by the 5. So it's 3 divided by negative 5 over 2. I want to make 3 into a fraction by putting it over 1. I'm going to first get the sign. A positive divided by a negative is a negative. So I know my answer is going to be a negative already. And then I'm going to go ahead and do keep, change, flip. Now I don't even need this anymore. So it's going to be 3 over 1 times 2 over 5. Here, once again, I'm going to check to see if I can cross cancel, but here I cannot, which is good. It means I don't have to reduce afterwards. And now I'm just going to multiply. 3 times 2 is 6. And 1 times 5 is 5. Like I said before though, a positive times a negative, or a positive divided by a negative, is a negative. So my answer is negative 6 over 5. In my class, you're allowed to leave fractions improper, so we are done.